season, MapleSim got released as an alpha project, and it was about like a week or two after I was like, oh, this is really cool. I want to try it. I want to try to see if it would be useful for our team. So we created this project in 2 weeks for the most part, and then it took another 2 weeks. And we kind of got some final stuff like vision working. And that's what you're seeing on the screen here. So this was our 5-piece auto that we had run in the season. We tested it in simulation, and it works pretty much the exact same way. And we were really happy with the physics simulation and how well it worked out. So, and some features we developed, like just to show like the different things you can do with it. We're simulating the drivetrain. It has collision detect, or with MapleSim you can collide with all the field obstacles. So if you run into the balls and in this case the truss from last year, it'll simulate that interaction. You got projectile motion tracking with the feed elements, so you can shoot into the speaker. It's accounting for gravity and stuff like that. You can shoot into the speaker in the amp. And we also have photon vision April tag tracking. So photon vision has the simulation elements with it, so you can simulate photometry and vision. But you can also use it to simulate things like game piece tracking. So anytime in this bottom one you see us going to pick up a note there, that's using photon vision to aim and drive towards that note in the simulation. So there's a lot of powerful tools. They come from different spots, like MapleSim, like photon vision, WPI library, and using all those, learning to use all those tools properly, you do some really cool stuff. And it's the reason this is very useful for us. This is our practice setup at home. So we have a quarter-size field carpet here, and only the right blue side of the field laid out. And we have to take this apart every night. So every night, if we want to practice, we have to roll this out, set up our field elements, and then when we're done at the night, we pack them all up, roll up the carpet. So it's really hard for us to, and we only have that one reef segment. So it's hard for us to test all these different positions on the field in like an effective amount of time. So simulation proved very helpful this year, especially with how many reef positions there are between the red and blue side, multiple autos you can try running. Yeah, we found it very helpful for testing all these different areas. Also, this place isn't tall enough for a BART, so we don't even have, so any of our net stuff, we don't have a net to test with, so we developed pretty much all of it in simulation, and then just fine-tune some stuff when we got to competition, because we did not have the ability to test that. One very useful thing, we've used it a few times, is for finding bugs. So this is an example. We've been developing a centerpiece auto for algae, and we realized we forgot to move the arm to a certain position before we did this motion, and it throws it in a more upward trajectory rather than into the barge like you normally would. So then we can just add another command into our structure, and that will fix that issue. Another one at the North Bay event, we had this weird thing where the arm was pulling back and dropping coral it was like every 1 in 10, every 1 in 12 shots. And it's packed up for the night. We went back to the hotel, still hadn't solved the issue. In simulation, we found out we were able to replicate the issue, and we figured out it came from a software issue in the command-based programming. We narrowed it down, fixed the issue, and in the morning we tested it in simulation and fixed it before we got back to the pits.
So all of our autonomous commands start development in sim, and we do pretty much 90% of the whole auto only in simulation. So we run drive to pose autos. So our entire autonomous routine is basically one big sequential command group where we drive to a series of points on the field, running commands parallel to that. So that's a new thing for our district championship we added. Before that, we were using Path Planner and Choreo. So all of them work in sim, all of them look good. Some of the things that we can tune directly in sim are our drive poses. So where we're driving in sim, we can see we're going to the right poses. We're not trying to drive into wall or gate to our drive poses, all of those sort of things. We can see our superstructure sequences. Superstructure is what we call the arm and elevator together. So we can see that everything is going to the right poses. They start, all of them are tolerance based. So once we get in a certain range of our target destination of the drive, we start raising the elevator early. We start tilting the arm early. Once we're almost at the top of our elevator distance, we start tilting the arm. We can test all of that in simulation. We can also test things like sensors. So we simulate our intake and algae sensors. We have a laser can on both of them. So we can see that our coral station command will wait until we have a coral before we start driving away. As soon as it gets the coral, it will start driving away. We can test all of those things only in sim. As Sam mentioned, we only have a quarter field setup. In this, we test both sides and both alliances. We can test all of that, see that it behaves exactly the same. This is basically just testing our field mirroring and alliance mirroring utils. So they should all be mirror copies, but it's good to be able to check that we're going to the right places. We can also test collision. So in certain spots, like the first placement to get to the coral station, we have to add a transition pose so it doesn't just drive straight through the reef. With simulation, you can see that otherwise it starts driving in, it's like driving through the reef and then kind of spins around. So we can add that transition pose and see that doing it properly before even using the real robot with practice set. This allows us, the real benefit of this is that we can leave the real robot for the things that are important. So at the beginning of the season, we can let the mechanical team do their job, spend more time making the mechanical part better while we're still developing autonomous routine. The things we actually use the real robot for when we're tuning autonomous is control system tuning, PID for the drive to pose, PID and V4 for all the arm and elevator motors. Motor and sequencing tuning, something I don't have up there, is physical world. There are quite a few differences. It's not a perfect simulation, so we can see where we're slow, where things are, especially also another thing I don't think has been mentioned, simulation on certain laptops is really slow, and it messes up. We can't really gauge how fast your autonomous routine actually is from the simulation. So you need the real robot to time it, see which parts are slower, which stuff you can speed up. That's the thing for the real world once you've done most of the main autonomous routine. Also elevator and arm poses, so where we want to go to, what height we want to go to, what angle we want to go to for all the branches. You could do that in simulation, but the real world, like our real reefs aren't perfectly accurate as they are in sim, so we usually implement that at competition, or we go book training ground and we check all the reef like heights and angles. Okay. Other cool thing, district championship, we saw that we were filling up the reef with our alliance partners. We were also getting all the algae off of the reef, and we can pick up ground algae. So we were wondering, okay, what can we do to get even more points? So we knew the lollipops were sitting there most of the matches. We're wondering if we could add a command that could do that. We were able to build this command sequence in 3 matches after qualifications, and it worked. We got 2 algae in our last match just using simulation. The training field was fully booked up. We couldn't use that. We were just in our pit. We were able to get the lollipop poses and build a command that would rotate towards it, drive in, wait until it's within tolerance for drive and rotation, and then drive in fully with the algae intake running the whole time as a deadline. And the whole command would end once we detect the algae in the intake. So that would be pretty much impossible without simulation. And the great part is that we can be pretty confident of how it's going to behave in the real world without even testing it yet. So we would not trust that if we just like wrote that code and we're like, yeah, just try it in like semifinals. We would not do that. Nothing like autoplays. So I was looking on Chief Delphi. I was looking at orbits, some orbit stuff. They showed their key bindings or their controller mapping, and I saw that they do branch selection with their driver joystick. I thought that was really interesting because what we were doing is we had buttons on the back of our Xbox controller. We're using the right and left ones to align to the right and left branch when we place coral. I like this a lot more. The driver does not have to take their hand off the drive joystick the entire match this way. And it feels way more intuitive to be like, oh, I want to go right, just drag to the right, left, drag to the left. So that's really nice. So I was like, okay, I should implement this. Only problem was our robot was being shipped to Worlds. So our robot's gone. So so I couldn't use it. Luckily, with Sim, I'm able to implement the whole thing, test it pretty much fully. As you can see here with the controller while I'm testing it, I can test it out from the driver POV. Yeah, this would not be possible without simulation. And now we can do the fine tuning here when we book the training ground, but pretty cool. Also, algae commands, as was mentioned, we don't have a barge to test on. So barge was pretty much fully made in Sim with some final tuning at competition. Processor sequence, also, we built that early in the season. We had that for its second competition. So we were doing a lot of mechanical changes, redid the whole intake. During that, I was able to make a processor command that worked first try. First try, I made it, got the pose, had the transition pose, elevator and arm height fully in Sim, and tried it out and it worked in real life. So once again, these are all the things where you can let the mechanical team make more changes while you're still making huge features that usually work pretty much fully, and you just have a small bit of tuning to get the final last changes so it works.
Perfect timing. Thank you so much for presenting.